Welcome to the Explainer. Today, we're diving into some of the most powerful and, let's be honest, sometimes tricky concepts in C++: arrays, C-style strings, and pointers. These are the absolute fundamentals, and by the end of this, you're going to see how they all connect in a really cool way. All right, let's jump right in.
So think about the data you deal with every day. Sometimes, sure, it's just a simple list, right? Like a list of employee salaries. A basic one-dimensional array is perfect for that. But what happens when your data gets a little more connected, a little more complex?
Exactly. Take a look at this grade sheet. A student's grade, like that 80, isn't just a random number floating around. It's a grade for a specific student, in a specific subject. That one piece of data is tied to two other things. To store this kind of grid-like data, we need to level up to a two-dimensional array.
Okay, so we can set up a 2D array to hold our grid. Awesome. But now, how do we actually fill it up with values? Are we really going to sit there and type out the coordinates for every single cell? No way. There has to be a better way, right?
Well, this is one way, the brute force way. And you can see on the left, it's just line after line of assignments. AR00 gets 1. AR01 gets 2. I mean, it works, but can you imagine doing this for a grid that's 100 by 100? Talk about repetitive, and it's so easy to make a typo.
The real key, the smart way, is to just spot the pattern. Look at how the column number just counts up. 0, 1, 2, 3. That's a textbook job for a loop. So if we can use one loop to fill out a single row, well, why not just wrap that loop inside another loop to handle all the rows for us?
And boom, here is the elegant solution: nested loops. The outer loop grabs a row. It says, okay, we're on row 0. Then the inner loop kicks in and just blitzes through all the columns for that row. Then the outer loop moves to row 1, and the inner loop does its thing all over again. It's a beautiful, simple concept that gets the computer to do all that boring work for you.
Okay, so nested loops are amazing for grids of numbers. But what about another super common type of data, text? You know, like a person's name. How do we handle that in C++?
Well, here's the big secret. In classic C++, there's no such thing as a string data type. It's really just an illusion we create. A C-style string is nothing more than a one-dimensional array of characters. So the name Ali is just an array where the first box has an A, the second has an L, and the third has an I. That's it.
But wait, this brings up a new problem, doesn't it? Let's say we set aside an array big enough for 50 characters just to be safe. And then the user types in the name Yasmin, which is only 6 letters long. If we tell the computer to print that array, how on earth does it know to stop after the N and not just print out the other 44 spots of random junk?
The answer is a really clever trick. At the end of the actual text, C++ automatically adds a special, totally invisible character called the null terminator. You see it there as \0. It's basically a secret stop sign for the computer. So when a function like count is reading the array, it just goes character by character until it hits that null terminator, and then it knows, okay, job's done, time to stop.
So, who's in charge of putting that all-important stop sign there? Well, it depends. If you're building a string yourself, one character at a time, then it's on you. You have to remember to put the null terminator at the end. But the good news is, if you're reading a whole string at once, like with sin, or defining it with double quotes, the system is smart enough to add it for you. Pretty handy. So far, we've been talking about what's inside the array boxes. But what if we want to talk about where those boxes are? To get that kind of low-level access and interact directly with the computer's memory, we need a new tool. And that tool is the pointer. Now, don't let the name scare you off. A pointer is just a variable. That's all. But instead of holding a regular value, like the number 5 or the letter A, its value is a memory address. It literally points to the spot in memory where some other data is living. This picture makes it perfectly clear. Check it out. We've got a variable x holding the number 5, and it just happens to live at memory address 100. Now look at the pointer y. It doesn't care about the 5 at all. The value inside y is 100, the address of x. It's kind of like having a variable that holds someone's street address instead of their name.
Now, to work with these things, you just need to know two key symbols. First is the ampersand, and. That's the address of operator. You stick that in front of a regular variable, like and x, and it gives you its memory address. Easy. Then you have the asterisk, star. This is the dereference operator. You put this in front of a pointer, like star y, and it's like saying, hey, go to the address stored in y and tell me what value you find there. It follows the pointer to get the data.
Now, I want to share a really crucial piece of advice that comes from the source material here. Pointers demand respect. They are incredibly powerful, but you have to be careful. The absolute best way to keep things straight is to literally draw it out. Draw the boxes, draw the arrows, just like in these diagrams. If you try to juggle all these addresses in your head, you are pretty much guaranteed to hit a wall.
And here's exactly why. On the left, you see a safe pointer. We've told it exactly where to point, to the address of X. All good. But on the right, that's a dangerous, uninitialized pointer. It's pointing to who knows where, just some random garbage address. If you try to use that wild pointer to change a value, you could be overwriting anything. Another variable, part of another program, maybe even the operating system itself. And that's how you get those dreaded program crashes.
Okay, so why go through all this trouble with addresses and pointers? Well, let's look at a super practical use case that brings it all together. Passing big chunks of data, like arrays, to our functions.
And here's where it all clicks. In C++, the name of an array all by itself is basically just a pointer to its very first element. Think about that. It means when you pass an array to a function, you're not copying the whole massive thing. You're just passing its starting address. This is incredibly efficient, and it's the secret to writing clean, reusable code that can work with huge amounts of data. We've covered a ton of ground. From organizing data in 2D arrays, to handling text with C-style strings, all the way to grabbing the wheel and manipulating memory directly with pointers. These aren't just abstract ideas. They are the tools that give you ultimate control over your program. So the real question is, now that you understand how this works, what are you going to build? Thanks for joining me on The Explainer.